Hello class, Dr. Mike here with some Python. Specifically will be topic 2, Python variables and statements. This maps to the textbook from Python for Everybody. There is a chapter 1 introduction you can go over, and there's chapter 2, so definitely goes over stuff. I'll do a quick demo just to sort of lead you down the path, but this is a really good reference, and there's probably videos also embedded from this textbook. But in any case, I'll give you my little take on it and we'll get kicked off here. So first off, you can see I have Anaconda open. I have launched my Jupyter Notebook and I'm here. I'm in Downloads Python Demos. I made a folder just for having some scratch work. I'll create a new Python 3 notebook and we'll call it week 2. And let's make this first one a markdown. And we'll just do, there you go. Look at that, nice markdown there. So again, without getting into all the definitions, a variable and statement. A variable is a placeholder for something. So it is usually referred to by a type, and we'll see those in the textbook, integer, string, and we'll talk about a couple of basic ones here. There's a longer list than that, but we'll keep it simple. So, of course, integer, number, and a string is text. But for now, though, let's go and create our first variables. Now, you've hopefully watched other videos where you've seen how to use Notebook, how the cells work, and how I probably talked about comments, but you can create comments with a pound sign. If I didn't talk about that before, there you go. Copy paste, right? This is unexecuted code. Unexecuted code is very common to see this in a lot of programming languages. Comments come in your code. Again, this is just an example of that. So first off, let's talk about variable names. Probably the hardest part of programming is kind of with the good names. There's always X, or you can call it var1, whatever. But to come with a name is tough. So variable names have some rules. And it should be outlined in the Python information about specifically the textbook. Talk about the names you can or can't use. There are certain things that are keywords. You can see here, and, delete, from, true, while, things like that. For, those are actually that's code. That's code statements. So also how it starts. You can't start variables with certain characters. You can't start with a number and so on. And so also spaces could be an issue. So a lot of times you'll see something called camel casing. And what that means is I want to create my first variable here. And so I can't do first, I want to make a variable that makes sense, right? So if I give you this code, you can look at it and go, okay, this variable is called first name. Let's just say first name. And it makes sense. Without even knowing what this normally is going to hold, you probably know off the bat. This is going to be someone's first name. So in Python, you put the variable name, you put an equal sign, and since this is a text string, I'm going to encapsulate it. And you notice when I did this, I put there once, and it actually created the closing quote for me. And this is something that Jupyter Notebook does. So I'll put Mike. And that's it. So that's my first variable. Of course, I can do last name if I want. And again, I'll use camel casing, but if I put ln for last name, it works too. And really, it's your code. For this class, you're going to write your own code and probably just debug your own code. And I'll look at your code, but I'm looking more at the output of your code. But if you work in an environment where you work with other programmers, other developers, other data analysts, having just X equal Mike and Y equal Labasi, X could be anything. So variable naming can definitely be something to tackle. So, but for me, I'll still keep them more make sense. All right, so I hit run. I run that. Now I don't get any error back again. This is normal. It's good. I have basically created 2 variables, And we have maybe demonstrated before, we'll talk about the first statement, or our print statement. You can use print a lot. You can just print something directly. If I run it, you see hello class. Or I can print a variable. Now I'm going to use some tab completion here. FIR, tab. There you go, first name. So take a couple tabs with tab there. Tab completion is nice. So if I print first name, and I can do 2 prints on the same line. Print, the tab key there. Last name. And there you go. Now if I change this, if I run this again, it didn't change. So why is that? So with the notebook, because it runs cells separately, this cell ran first. Even though I ran this again, you see this now has an indicator of 5. It's been run 5 times. If I run it again, I'll get 6. This output hasn't changed. These variables have not actually changed yet. I changed them in the box, but to write those, have the kernel write those into memory, I need to run it again. Now if I run this, it changes. So keep that in mind. You start having longer Python notebooks and you're doing some research, maybe here you have a threshold number you set, you run it, and then later on you change it and you run your, you don't run the cell, you run it later on further down and you go, well, it hasn't done anything. Make sure you verify your variables. And that can be done by simply just printing them out. As a quick test, right? So what can we do with this string? Start with strings here. So again, what is a string? So first off, let's talk about how we can see what our variable is. Let's create another one up here. Let's call it num. Again, variable names, right? 42. Again, I run this. That's fine. That hasn't changed. Let's print num. There's 42. So is 42 a number? Is it a text string? What kind of number is it? Is it a long? Is it an integer? Is it a float? You know, floats. Think of floats as decimals. Integers have non-decimals. So that's probably explained here. When we talk about variable types, there's probably something in the textbook. I don't want to bring it up here on screen, but something to look for. Variable types. Also, don't forget the help here. A lot of good help here. Python reference. Tons of stuff here will help you figure out tutorials. Start here, library references. So, but again, I got off track here. Let's go back here and talk about how can we see what type it is. So let's talk about how can I interrogate a variable and see what type it is. Well, there is a command called type. If I type correctly, type. I put in the variable name. So let's put in num. Let's do another one for type for last name. If I run those, okay, so this has overwritten this one. So you do 1 type per cell. Because you don't see the first one, this ran and then it's cleared out when this one came out. So you can do a print type num, and it should give me both. So just FYI, sometimes you can overwrite stuff. Type will do this, I know I've seen this before. So you can insert a print inside there. And inside the print, I can run this statement to give me type. So keep it simple though. This is type last name, run string. So type num is integer. So type command is fantastic. It's going to help you figure out what the variable is. So let's come back and we're going to look at string specifically. Just a little bit here. I think we get into strings a lot. We're going to talk about more and more during this class. So I just want to give you a quick note though about strings. Strings have different things about them. You can get information about a string. And one of the commands we can use is our length, or len, L-E-N. So I do len, and let's do last name. It is 4, because last name is Mike. That's first name, I guess, but MIKE, it's for length. So pretty straightforward. So you can judge the length of stuff. If I do length first name, let's just do tab completion. You can see it's 2. So there you go. So you can, these strings also have ways you can interact with them. We can append them together, we can split them. You definitely can do string splitting. I'll definitely do in the course. So I'm going to come back to that too. I don't want to get too much into it. Here is want to demonstrate how I set the variable and I dealt with it. But strings themselves, I can do this. Let's go ahead and say, let's create a set one called sep equals, and let's put dot smiley face dot, right? So I have this thing called sep. Again, what type is sep? It is a string. So we can actually sort of concatenate strings together. So I can do this. I could say call string2 equals, and I can actually add 2 strings together with a plus sign, or even easier, just print. Let's print first name, and I can say plus, and what was that, sep plus last name. So, and you can even insert this type of plain text. So let's go ahead and do what we could do. Awesome stuff we can do here. We can actually just put a string inside here. Create our own little separator. If I want the space there, look a little neater. So we can, the plus sign, we can sort of concatenate strings together, add them together. And it sounds funny adding strings, but you can do that. Very powerful way to sort of manipulate our string data. Another thing we can do too, besides just add stuff together or get the length, we can actually change stuff too. So let's go ahead and there is something called upper. Now I'm going to show you something here in Notebook, and within Python it's going to allow you to go ahead and it's calling subfunctions. So since let's use last name. So let's go ahead and say, let's create a new one called upper ln. And I can actually take a variable and plug it into another variable. So upper ln is going to equal, this is a brand new variable, equals last name. And here's the thing, I do dot tab. Dot tab, you notice I have here a list of things I can do. These are string operators. And you'll see this with all kinds, not just strings, all kinds of stuff. We're going to see this dot operation all within Python to the course. You can look them up, all the different operators. Because this is a string though, we can actually do it. We can format it, index it. We can ask, is it lower, is it upper? So I can actually interrogate a string. I can like parse through data and say, hey, is it lowercase? If not, and you can see I can sort of use this in data analysis, right? If I have a data set where I expect one of the variables to be true or false, all uppercase, I could check my data set, check this variable, and we haven't gone through loops yet, but loop through this data set and check this variable. If it is lower, then print out the line number or give me a tally of the number. Things like that. That's just an off-the-cuff example. But we can change it. We can actually change this string splitting. We're going to come to string splitting later, but we can make it upper. And then what we would do is we want to actually identify, we want to make upper ln, and we sort of leave this here. This is a function itself, and we leave it empty. Run that, and if I print, I'll come back to that in a second here. If I print upper L last name now. I got, well, that's my first name. I got uppercase Mike. So the dot tab is going to open this up. I can see all my options I can use because last name is a string. I have certain options I can interact with it with. One of them is to make it all uppercase. And so I had to end it with this. So upper is actually a function. And if you've done programming before, this sounds familiar. We need to leave a blank open and close here. Sometimes you actually can put stuff inside these, and that's going to be later in the course. We can modify some stuff, but this is really a function call for a string. So, but to keep it simple, remember your dot space, dot tab, and you can see I had different interactions with this string. So very, very cool. So let's talk about, I think we'll come back to integers and floats later. But no surprise, if I have num1 equals 42 and num2 equals 10, I can make a num tote, which equals num1 plus num2. And I'm going to do something different here too. I'm actually going to put print numtote. You'll see my tab key a lot here. 52. So again, no surprise, since these are integers. They're numbers, you can add them, subtract them, multiply them, and so on. I won't get too much into that. There's an order operation, and some examples in the textbook. So if hour is actually a number, I can say hour times 60. So you can actually call it by the variable name. So a lot of stuff here you can see. Remember your order of operations mathematically. If you're doing some, if you create an algorithm, maybe you're computing pay or computing some sort of percentage on something, and the percentage is off of a computation, you want to maybe force it into parentheses first to ensure you get that computation first, then get the percentage of it. So, anyways, string operators here, they talk about it here too. Asking for input, this is a good one. So we can actually, you'll see in the class later, we'll get input either really to set it manually like we did here. We'll load it either from a data set, and I say data set, that could be a CSV file, Excel file, a database, scrape from a website, you name it. But, and we're going to really do that other one where we load from a CSV file. You're going to come to that a lot. But for now, though, and that's when we get into looping. But for now, though, how can we prompt the user for something? So let's go ahead and do that. So let's create an input statement. All right, so I'm going to create one called, let's do a little quick payroll program here. So I'm actually going to make a markdown cell here. Pay program. I'm going to insert some blank cells here just so I can scroll up. So I did that right there. So I kind of at the top of the screen there. All right, so we're going to create a program or a little algorithm, program, quick program. I say program, a Jupyter Notebook app that's going to run this for us. So first off, what I'm going to do is, I have some in mind. I'm going to actually in comments put down what I'm going to do. I'm going to get hours from user. Then I'm going to get, I'm going to set pay rate, set a pay rate. If I can type correctly, pay rate. Then I'm going to compute total pay. And that's going to equal pay rate, pay, yes I can type rate times hours. Then I'm going to print total pay. So it seems funny, I'm doing something called pseudocoding. I'm just sort of in my mind putting down in comments what I want to do. What does it need to be? And it could be I'm given some sort of guidelines. It could be you're given the guidelines, say, hey, I want you to compute pay, get the input of the hours from the user, and then pay rate, set the pay rate to a flat amount, and then just compute total pay and print it back out. Say print or echo it back out or put it back in the output of the Jupyter notebook. And so having those requirements, and I actually may copy and paste those into just a raw text field, so I have them here to look at, make sure I actually meet those requirements. So with that in mind, we're going to do a few things. We're going to set a pay rate, we're going to get the hours, and we're going to do a computation, and we're going to print it. So quick little program here. So variable names. So first off, let's go ahead and get the hours. So I'm going to go ahead and I'm going to call them hours. Now equals, and I'm going to do input. There I am. Input. You know, to turn green there. Input. I'm going to go in and put a prompt, say enter hours. So that's a simple input statement. Now, I'm actually doing something wrong here on purpose. So if you're screaming at the screen, no, Dr. Mike, you're missing something. No, I'll get to it. So again, we're saying this variable is going to be whatever is inputted by the user. So I'll run it. I get this, enter hours. I'll put 42. Enter. Now, I didn't see anything back yet, right? So let's do print hours. I can do it here, 42, or I can do it here. Print. Let's do something cool here. Let's say you entered, and then a comma here, hours. So I can, on a print statement, put in a text string, and then with a comma, I can add more text, or I can actually put a variable. So it allows me to have to keep from doing this. Let's delete that cell. Nice and clean here. Now I can do this again. I'll put in 42, you enter 42. It's a good way to verify it. Now, there's something about this variable here, hours, which I haven't come to yet. So let's just try something real quick here. Let's continue our program. Let's do our second part, which is set our pay rate. This is going to be hard-coded. So I'm going to call it rate equals 20. And I'll say print current pay rate is, comma, and I'll put rate. So, big deal. I mean, it's a way to verify. I'm sort of verifying it. Maybe I don't see the underlying code. I can verify the pay rate. So cool, that works. Let's go ahead and copy that, put it up here. If I run that, I get, okay, enter hours, 40. Enter 40, my current pay rate is 20. Cool. So you can see you can actually do chunks of it in different cells, or you can put it all in one cell. So let's actually continue on. I'm just going to work in this one cell here. All right, cool. Now my last part, I'm going to compute my pay rate, my pay. So pay equals what? Equals rate times hours. Now there's a catch here. And I'm going to have an error on purpose. And let's finish off here. Print total pay is pay. Now if I run this, I should get, okay, I'll put 40 hours. Well, that's weird. That's a good paycheck, isn't it? Wish I'd take on a paycheck. 40, 40, 40, 40, 40, what? Okay, so I did this on purpose because I want to show you that this input field, how it operates. Let's do a quick thing here. Let's do a type check. TY type on hours. It's a string. What? Why is it a string? So the input statement by default brings in everything as a string. So you're like, well, that's not going to work. How can I get this into I need it as an integer, let's say. Or even more important, maybe I want to use decimal hours. So again, it's the kind of stuff you would ask. Get hours from user. Should it be decimal or not? We'll say just no decimal. We'll keep it simple. no decimal, right? So I come back, I ask, they say no decimal, make it, it's going to be just either, flat number. So, okay, I need to make this an integer. How can I do that? So, a few ways you can do it. One is, after you enter the hours in, I can actually take hours again and equals int hours. So this is forcing or changing the variable type. So it's called type casting. You can do it here. Now if I run this, enter hours, 40, I think it makes more sense now. If I do it here, it's an integer. And I can do it here if you want. That's H-O-U-R-S, hours. You can do it here as a separate line, and that's perfectly acceptable, or you can do it in line here. If I wanted to, again, this is a function, and in here I need to put stuff, so I can actually wrap this inside of this. And the way I do that is, I'm just going to comment out this piece of code. That won't run anymore. I could say integer. So some will say, yeah, it's more Pythonic. That's a word you'll hear a lot. This is more Pythonic, to have it all in one line. And that's fine, or you can have it as a separate line. Now this is commented out, so this won't run anymore. This is just now just this text. But what it does is now is it will take whatever this gets, which is a string, and it's going to turn into an integer and put it into this variable. So it'll still work now. So let's put 80 hours. Enter. So if I, of course, run this again, you'll see it is an integer. Now if I want to make it a float, let's run that. Again, I could put 66 hours. You know, so I got a decimal in the total pay. Let's talk about that. So if I say type hours, now it's a float, so that's decimals. Let's actually run this again. Let's put in someone worked 40.5 hours, half hour overtime, right? So how come pay is a float? So Python does not have a strict. Some programming languages are strict, where they're type strict, where you have to say hours. You know, I got to declare hours as a float, and then I put some into hours. Python allows you to sort of just declare it as you use it. And you notice I never actually, and declaring means, you know, hey, make pay a float. I didn't have to. I just say pay equals rate times hours. And what Python does is it goes, okay, well, I see rate, and if I do rate here, because rate's a single digit, you know, it's basically, there's no decimal, it's going to be an integer. But however, I see that my hours is coming over as a float. So I'm going to make myself equal float. So pretty nice. It will actually automatically adjust the output for you. So pretty cool way for Python to handle our numerics there. And that should wrap up the demo here. This hopefully gives you a little leeway into it. Again, look at the textbook. There are videos that come with the textbook. They're going to go into a little more greater detail than I did. And there will be in the learning activities. Yeah, there's 2 videos that come from the textbook, and there's a reference here, which I just linked to, which you'll see open here, which is a good reference also. So in case, hopefully I at least give you a quick demo about how I would approach and just some highlights of variables and statements. Thank you.